Hey guys, we're going to make a short little video here to look at heating curves of water. So let me put the screen down there for a second. All right, this is the diagram that's uploaded for heating curves, and this one is particularly water. If you have this and it's printed, that's awesome. If you can't print it, that's fine. Pause this, grab a sheet of notebook paper, and very quickly draw yourself a little graph that looks like that. You don't have to have the whole box. You just need to have your, X and Y axis on it. Okay. And then let's go. So we're gonna go over the very basics. The first thing you guys need to know, you're gonna learn a few different graphs with this particular unit for thermokinetics, as we call it, which is thermochemistry and kinetics combined together. This is a heating curve, and the most important thing you need to know is really how to read it and how to answer questions off of it. After your graph that's in the handout I gave you guys digitally, you guys would also have access to the questions that go with it, and that's your actual assignment. If you go through this video, which should take under 10 minutes, then you'll be able to go through and answer all the questions without too much trouble. Keep in mind, this one's for water. It's the most common example. It's water. However, on test or in any other situation in life, you may not be given water as your substance. You might be given alcohol, ethyl alcohol, ethanol, ammonia. There's a lot of different substances that you might see. They're usually the more common substances. First of all, let's look at the two things that we have here. It says it's the heating curve of water, heating meaning you're heating it up. And then you have your x-axis and your y-axis. So take a look really quickly. And down here on your x-axis, let me switch pens really quick. On your x-axis, you've got the heating over time. So that means we're heating it over time. There's no numbers down here. So that just means that time is past 1 minute intervals. So if you were to label it, it would, 1, 2, 3, 4. These are over minutes. You've got the temperature, and it's in Celsius. Always remember that we use Celsius, and that's super important when you're looking at this particular graph. We always use the SI unit for Celsius in chemistry class. In any academic science class, you're going to use that, but it's important today so you know what these numbers even represent. Remember, this is water. Water has certain physical properties that you guys all know. There's 3 phases of matter, solid, liquid, gas. You should know the melting point, boiling point, things like that. So let's look here. You've got a graph that starts kind of low, goes up, flattens out, goes up again, flattens out a little bit more, and then goes up one more time. So it has 3 areas where it goes up. I also noticed that I have an arrow going up here and an arrow going down here. Okay, and that's important. That lets you know that it can go this way, but it can also go backwards towards the left or down. Okay, so focus on that. So let's look over here. And the first thing you need to notice that in temperature and degrees, you're starting your very first point over here. Your coordinate is a -20. Okay, here's 0. This is -20 and -40. Keep in mind, this is water. What do we know about water in Celsius at degree 0 right here? A couple important things that you need to probably label on your graph. The first thing would be this 0 degrees. In Celsius, we know that this is the freezing point of water, or in other cases, depending on which way you're going, it's the melting point. So if you're already an ice cube, you can't freeze. That would mean that you need to melt, right? So it depends on which way we're going on this graph. If you're an ice cube and you're increasing temperature, you're going to melt. If you're liquid and you're decreasing temperature, you would freeze, right? Then let's kind of fast forward up to the top up here, and we have another important number, 100. 100 degrees Celsius is the boiling point or vaporization point for water. Okay, so 2 important numbers. The next thing that you guys need to look at is we're going to start going away from our y-axis with this number, this arrow over here. So the first thing that I would look at is go, okay, well, I've got A, B, C, D, and E. A is this segment here. It's increasing. It's starting at -20. So what is happening between -20 and 0? The temperature is doing what? In this case, the temperature is increasing. It's going up. So the A down here is asking you really, what is that right there? What phase of matter is that going to be? And because this is the matter that we're talking about here is water, what phase is that water going to be in? Well, if it's always below 0 degrees right here, what does it have to be? It has to be a solid. Okay, so we usually call that ice, right? Okay, and then you have this flat area right here. We call these a plateau, just like the geographic feature, mountains and plateaus. Okay, let's skip B for a second. Let's come over here to this part because we noticed that this stayed the same temperature, right? It was at 0 and it's still at 0. So right here, we're going to start at 0 and we're going to increase temperature all the way up till we get to right here. And if I was to follow this line over to my y-axis, I would see that this is at 100 degrees Celsius. Well, what do we already know happens at 100 degrees Celsius? Water boils. So at 0 degrees, it has melted. At 100 degrees, it's now it's boiling. It's turning into a vapor, also known as a gas. Okay, so what phase of matter do you have here? If it's in between melting and vaporizing, it would be just traditional liquid. Okay, and we don't know that because it's like this huge long line or because it's in the middle of solid and gas. We know that because we look at our numbers and it quantitatively, without question, tells us 0 is where stuff melts, water melts, and 100 is where water turns into a vapor. Okay, then we're going to come over here and we're going to look at this flat second level. We call this another plateau. Okay, and then you got E. And E is still at 100 degrees because this is flat. So you're still at 100 degrees. E is going to start at 100 degrees and it's going to increase. Okay, so as E increases, once you hit 100 degrees, is it a liquid anymore? No. Now what is it? It's a vapor. Or you guys would call it a gas. Okay, so you might get a lot of questions about what phase of matter is, this substance in at point A or at point C or point E. And you just very simply have to look and figure out based on the temperature what phase of matter is going on in there. Now, the question remains, we didn't label these areas. We didn't label B and D. We didn't label your plateaus, okay? These are increasing or it could be decreasing if you're going this way. It could be just the same that, you had a pot of water on the stove and it was boiling and you turned off your stove. Well, what's going to happen now? You've removed heat from that pot of water. What's happening now? Well, it's going this way. So it was a vapor. Now it's going back down. Temperature's going down, 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 down. And it's water. It's liquid water. And it's going to stay that way. Now, it would only freeze if you put it into a container where you could lower the temperature, such as a freezer. Okay. So keep in mind, this goes both ways. You can heat it up. You can cool it down. The question is, what about these plateau areas? And if you think about it, is there an immediate moment where a substance goes from a solid to a liquid? Does it just happen instantly? If you put an ice cube out on your countertop and watch it melt, does it immediately melt? The whole thing melts at one time? Or is there perhaps a time period where it's a little melted and a little not melted, as we would say in layman's terms? This plateau right here is the actual phase change. And the same thing up here. Okay, this phase change is where you have a little bit of solid. You have some of the water, H2O molecules, because all this is H2O on this graph. The substance hasn't changed. You've got a little bit of it acting like a solid, meaning it's not taking the shape of its container. It is what it is. If it's a square, it's staying a square. And you've got some of it that's acting like a liquid. So it's behaving more like a liquid would. It's taking the shape of its container. If you left an ice cube on the countertop, that's a very large container, and it's spreading out, making what we call a mess. If you look up here, you've got point D, the same thing. This is your other plateau. This is where the temperature isn't increasing or decreasing. Your substance is behaving a little bit like a liquid, some of the particles, and some of the other particles are behaving like a gas. This is the actual phase change where you go from one to the other. So you either spent your time as a liquid and you're becoming a gas. You were a gas, now you're becoming a liquid, you're condensing again. But it's important that you guys can identify, that's your standard for the students to be able to look at a heating curve, identify what the plateaus are and what they represent, and what these other three phases are. Always remember to look at your axes, make sure you know what substance it is that you're dealing with. and make sure that you can label these areas in between. And it's very simply that this is kind of the in-between phase between one phase and another. This is your actual phase change where that substance is moving from one behavior to another, and it's going to, in this case for liquid, stay that way for quite a while and plateau out again as it switches from one to the next.